Welcome. This playlist of videos serves to provide teachers with content support for the third grade first quarter math standards. In this first video, I will provide a brief introduction for some of the standards as well as tips for teaching some standards. In weeks 1 through 5 of the first quarter, we focus on rounding, fluency with addition and subtraction, and then creating graphs and solving addition and subtraction problems involving these scaled bar graphs and picture graphs. I'm not going to spend much time discussing 3MD3 because this seems to be a standard that causes the least amount of difficulty for students. However, I do want to point out that most of the time spent on MD3 should be on the interpretation of the graph and problem solving, not on the actual creation of the graph. This standard is a great opportunity to provide real-world situations for solving problems and developing skip counting before getting into multiplication in the second quarter. As the unpacking document states, be sure to provide a variety of scales on your pictographs and your bar graphs to help students get skip counting experience using a variety of numbers. One of the really important standards in the first quarter is 3NBT1, which is our rounding standard. Rounding should be introduced at the beginning of the year so that students can use rounding all year long to estimate or to predict their solutions to problems and then to check their answers for reasonableness. Now, I know rounding is a really difficult skill for third graders, but please don't linger on this standard for an extended period of time. Just be sure to use rounding throughout the year as you make estimations and to check the reasonableness of answers. The main standard that I will be discussing from weeks 1 through 5 is 3NBT2, which is our fluency standard. This standard asks students to fluently add and subtract using strategies and algorithms based on place value, properties of operations, and the relationships between addition and subtraction. Please remember that fluency is not often mastered in a short unit like this. This unit is when strategies can be introduced and practiced and algorithms can be introduced and practiced. However, these strategies and algorithms must be used across the year in order for fluency to be achieved by the end of third grade. One thing I wanted to point out here, as you teach third grade, you will notice there are no place value standards in this grade level. That's because we are now taking the time to apply our place value concepts from first and second grade to the rounding standard and to that fluency standard. That's why these standards both mention using place value to round and to develop fluency. As standard NBT2 states, students should use both algorithms and strategies to add and subtract fluently. Now, an algorithm is a set of predefined steps, and when these steps are implemented correctly, they will always lead to the same result. Versus a strategy is purposefully manipulating numbers in order to make computation easier. The algorithms that I'm going to be sharing with you today come from eduplace.com or eduplace.com. I'm going to put the link below this video on my YouTube channel so it's easy to access. Every grade level on eduplace.com has a list of accessible algorithms for the grade. The ones that I'm going to be looking at today are the accessible algorithms, same as alternative algorithms, for addition, and then the accessible algorithms for subtraction. And when you click on those, you will get a document that looks like this. It's very print friendly. This will be a great tool to print out and use for your parents. When you introduce algorithms to students, model and practice each in isolation. If you introduce too many algorithms in a short period of time, students will not understand them or be able to use them proficiently. It may take a few days to thoroughly understand the process and reasoning behind a single algorithm. I will probably only teach maybe 2 different algorithms for addition and then 2 different algorithms for subtraction, realizing that I will introduce a few strategies as well. Start with easy to understand algorithms like show all totals. Here you have an example of show all totals. Here the student is working from left to right. Here the student's working from right to left. So here I would say 200 and 100 makes 300. So I write down 300. And then 60 plus 20 is 80. and then 8 plus 4 is 12, and then I would add them all together. Now if I was working from right to left, this is a little bit closer to that standard algorithm. We're moving us a little bit closer to that direction. I would say 8 plus 4 is 12, 60 plus 20 is 80, and 200 plus 100 is 300, and again, add all of my totals together. You can also show this problem in the expanded form, and then that way students can see each of the values of each of these digits within that number, and then it is a little bit easier to understand. After I've taught the show all totals algorithm for addition, which is closely grounded in place value and helping students understand how to write numbers in expanded form, then I would move to that more abstract algorithm, that traditional way, that standard algorithm that parents typically teach their students. Now there's two ways to record as you do the standard algorithm. I'm going to show you the way that we've seen first, which is just as you regroup, so 8 plus 4 is 12. I would put the tens above and I would record the 2 below. Now, for me, that makes sense because I've been raised that way and I've been doing that all my life. But there is another way that we could record this. So this time, instead of adding 8 plus 4 is 12 and putting the 10 up here, I would record the 10 below. And this is just the same thing, but it's called new groups below. And that way we can easily see that that's a 12 versus the 1 kind of floating up here and students getting lost with the meaning of what does that 1 mean. Again, for subtraction, you will probably want to choose 2 different algorithms to teach. Start off with an algorithm that's easy to understand and grounded in place value. For example, the ungrouping strategy. With the ungrouping strategy, again, you can either work left to right or right to left, but what the students will do is they will ungroup every place prior to subtracting. So I would ungroup the 500s, put 400s here, and move 10 10s over to the 10 place. And I would ungroup one of my 10s and move it over to 10 1s in my 1s place, and then I could subtract very easily. If this is hard for students to understand, and it will be for some, then you could write the numbers in expanded form prior to ungrouping, and then it's a little bit easier to see what's. But hopefully, because we've done a lot of work with a place value here, then when we get to that standard algorithm, they will still have that understanding of why that standard algorithm works, because it really is grounded in place value.